In this video, want to demonstrate how we used this research article that identifies the tail of the gamma subunit. There's an alpha, beta, and gamma for laminins, in particular laminin 5 for our work, as they're showing here. And with the carboxy terminal tail of the gamma 3 subunit, there's a glut residue, turns out to be 1170, and it binds to tyrosine 133 that they identified on here, that I will be showing you in the VMD 3D image. This is a picture of the reconstructed laminin 5 alpha, beta, and then blue is the gamma subunit. This is a membrane, and the alpha 3 beta 1 integrin is there, and it's spanning through that. I'll flip through a couple of these. You can kind of orient. Here's the beta 1 and the two residues, the tyrosine 133 on the beta 1 and the 1170 glue on the gamma subunit. Black is the other subunit whose carboxy tail, the beta subunit whose carboxy tail comes in here as well. Anyway, and then these are the subunits surrounding the that hold it all together for the alpha 3. This is the beta propeller head of the alpha 3 integrin subunit, and here's the beta 1. So I'm going to do a forced, a steered molecular dynamic simulation. I'll show you an early simulation here in this one, but anyway, I'm just showing how based upon this binding site, I'll be pulling this residue up in this direction away from the membrane. We'll just close this. I got a few other pictures here you can go through. You can see that they're above the membrane, and then even in the bent form, this is what we're going to see back here. So I've now added the magnesiums, that is the admitis, the mitis, and the LIMBS. These are our two residues. We only see the gamma subunit, a portion of it here. We can see it goes up, extends above the membrane. Here's our XYZ, so I'll be steering the tyrosine 133 residue at the very tip of the alpha 1 helix of the beta subunit, integrin subunit head. I'll be pulling that in this direction. Here's the calcium and the propeller. Here's the beta subunit residue that is in what's called the dimple of the face of the propeller. Anyway, through the interactions between the alpha and beta heads here, by pulling this, we should be able to extend it. There's the calcium in the knee of the alpha 3, so we should get the unbending of the knee and then the opening of the head. I'm going to pause now and set up, show you a little bit of the simulation. Okay, so we should be back. First time I've tried to pause. Now what you see is kind of a top view of just the beta 1 integrin head. Let's see, here's the tyrosine 133, and we come back. This is the alpha 1 helix over here. This would be the alpha 7 going down over there, and the loop. Here's the admitis, mitis, and the LIMBS. Have magnesium in here, and you can see some of the residues and the waters. Right, there's not a lot happening in this simulation. This is just where I'm letting the molecule kind of relax and get used to having the magnesium in there. You can see, I'll just jump from this is the last, this is the beginning. What I've got here is about 150 maybe picoseconds of simulation. So from here to here is 150 picoseconds, and you can kind of see the opening up and the relaxing of some of the helices. They're pushing away from the manganese in there. So with the manganese and the pull to mimic the binding of laminin 5, we should get the extension of the head, changes in the alpha 1 helix and the alpha 7 helix, and then down there you see the hybrid domain. They should separate. I'll just kind of do this, rotate it a little bit, and scale back a little bit to let us see if there's any. So that's the beginning, that's the end. Doesn't really look like it's okay. So this would be the way to look. We're watching for this to move away from that. So here's the beginning. So in this number of picoseconds, it's just kind of a loosening, but you'll see that there's an arching of the alpha 1 helix if you look closely. Boom, so it's starting to build the tension to begin to push. So I'll let it run for a few more days, and then at the end of this run, I'll start there to start the steered.